everybody. Um, my name is Owen, and I will be presenting sprint number 30 today. So, just to read the question really quickly, Paulina is playing a game with Harper in which she flips a certain number of fair coins one after the other. When a coin is the case to come up heads, Paulina receives K dollars. If Harper wishes to keep the game completely fair for Paulina so that her expected profit is zero, but does not wish to charge her more than $100 to play, at most how many coins can he allow Paulina to flip per game? Okay, so just getting started, the first step that we should do is compute what is the expected value of dollars that Paulina will get from this game. So if she say she has like T coins total and that X of them come up heads, then because she's receiving $1 and then $2 and then $3 and so on up to X dollars, we will get X times X plus 1 over 2 total dollars if she flips X heads. Now this is the number of dollars that she gets for flipping X heads. So to get the expected value that she will get from this game, we multiply this by the probability that she flips X heads and sum that over all possibilities. And so here we can see the equation X. So this X is equal to our expected value. You can see here we have a binomial coefficient divided by 2 to the t possibilities, multiplied by what we said her profit was, or not the profit, how much she earns. So now what we want to do is evaluate the sum in terms of t. But unfortunately for us, this is kind of difficult to do. So first we're gonna look at a related sum that's gonna be a little bit easier to evaluate. So I have written this as A. A is equal to this thing, except instead of x times x plus 1 over 2, it's just x times. And the trick here is that we can actually pull out a t and an x of this binomial coefficient. And the reason we want to do this is because x changes with the summation while t will stay constant. So we would like to be able to cancel out these x's. And since x equals 0, when x equals 0, this inside term is just 0. We can actually start the summation from x equals 1 and the value does not change. And actually, when we divide out everything, we can rewrite the inside as another binomial coefficient. And then the outside will be t over 2. And the reason I pulled out this 2 is because if you look at this sum now, this is actually just equal to 1 because it's just adding up the total number of ways to flip, for example, t minus 1 heads, or if you know binomial coefficient sum identities, like that would also tell you that this sum is actually equal to 1. So A is actually just equal to t over 2. So now we would like to be able to do something similar with our original sum x. Unfortunately for us, this x plus 1 term in the numerator is not going to be able to cancel with anything in the denominator. So we can't be able to do this directly. But notice that what we can do is instead evaluate this related sum b, which is very similar, except that instead of this plus, we have a minus. And the reason we're doing this is because we want an x squared term somewhere, and we get this x squared term by multiplying by x minus 1. And now we could do something very similar to what we did on the left side here, and we will be able to get t times t minus 1 over 2 squared times a thing that is equal to 1. And again, notice here that like x equals, this summation down here is x equals 2 because the terms when x equals 0 and 1 are just 0. So we can ignore those terms completely. So now we can actually write x in terms of a and b as b over 2 plus a, and this is just, we can get this from just matching the higher order terms first and then going down lower terms. So we need to divide b by 2 to get 1/2 x squared, and then we have a minus x over 2 term, so we will need to add x to get the plus x over 2 term that's in x. So that's where b over 2 plus a comes from. And just evaluating this in terms of what we said b and a are equal to, we get t times t plus 3 over a. And finally, by the problem, we're trying to find t, and we know that we want the largest value of t that will make this expression less than or equal to 100. And we can just do some basic algebra So if t is 27, for example, we get 27 times 30, that's 810, that's just over 800. So by subtracting 1, we can test 26 times 29, and that will be under 800. And so our final answer is going to be 26. All right, thank you, everybody. That's the whole problem.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.